Okay, let's dive right into this. Welcome to The Explainer. Today we're tracing the absolutely revolutionary evolution of digital money. It's this incredible story where technology, economics, and, pure ideology just completely intertwine.
Now, this entire journey is brilliantly captured in Ethan J. Monroe's book, Cryptonomicon. Our story actually kicks off way back with the 1980s cypherpunk movement and their really vital mission to protect digital privacy.
So here's our chronological journey for today. We're going to trace the path from 1. Cypherpunks to Bitcoin, 2. The mechanics of blockchain, 3. The rise of altcoins, 4. Blockchain beyond currency, and finally, 5. The decentralized future.
All right, Section 1, Cypherpunks to Bitcoin. The origins of digital cash, and that fundamental quest to reclaim power from centralized institutions.
Privacy as a fundamental right. This core principle literally fueled the entire cypherpunk movement. You see, they looked at strong cryptography not just as lines of code, but as a crucial weapon to empower regular individuals. They realized early on that in a highly digital world, true privacy didn't just mean hiding your information. It meant having the actual autonomy to transact without some kind of undue surveillance watching your every move.
So, throughout the 1980s and 90s, we saw all these escalating attempts to create decentralized money. We're talking about David Chaum's digital cash, Nick Szabo's BitGold, and Wei Dai's B-money. But, well, they all kind of hit a brick wall. Specifically, something called the double spending problem. That is, until 2008. Right at the absolute peak of the global financial crisis, the enigmatic Satoshi Nakamoto drops the Bitcoin whitepaper. And this massive breakthrough culminated in the Genesis block of 2009, which, let's be honest, forever changed finance.
Moving on to Section 2, the mechanics of blockchain. Now, what's really interesting here is the ingenious technological machinery that makes Satoshi's vision actually work in the real world.
Okay, the absolutely crucial concept to grasp here is proof of work. It's a consensus mechanism that requires miners to solve these incredibly complex mathematical puzzles. And this computational competition is just brilliant because it completely replaces the need for a central bank or any trusted intermediary. Basically, miners expend real energy to secure the network, and in return, they get rewarded with newly minted coins. It creates a completely decentralized trust system from scratch. Let's actually walk step by step through a peer-to-peer Bitcoin transfer so you can really see this in action. Step 1, the sender signs the transaction with their private key. That proves cryptographic ownership. Step 2, unspent transaction outputs, or UTXOs, which are basically like leftover change from your previous transactions, are referenced as inputs to prove the funds actually exist, and new outputs designate the receiver. Then, Step 3, the miners step in. They verify these digital signatures and make absolutely sure there's no double spending going on. Finally, Step 4, once everything is verified, the block gets permanently added to the chain. Boom, pure disintermediated trust.
Which brings us to Section 3, the rise of altcoins. This was a massive explosion of innovation, specifically designed to solve new problems.
Let's look at the first really major divergence, Bitcoin versus Litecoin. So Bitcoin is often called digital gold. It uses 10-minute blocks in the SHA-256 algorithm. But then in 2011, Charlie Lee comes along and designs Litecoin as digital silver. By using faster 2.5-minute blocks and a memory-intensive script mining algorithm, Litecoin was engineered specifically for quicker, everyday microtransactions, and also to democratize the mining process a bit more.
Next up, we have to contrast transparent public ledgers with shielded ones. Now, Bitcoin's ledger is completely transparent. Literally everyone can see the addresses and the transaction amounts. But privacy coins like Zcash, they take a totally different approach. They use zero-knowledge proofs, specifically something called ZK snarks. It's this wild cryptographic breakthrough that actually allows users to verify a transaction's validity without revealing the sender, the receiver, or the amount. It's a really fascinating technological balance between public verification and strict individual anonymity.
If you find this analysis valuable, please like and subscribe to Knowledge Lighthouse to help us bring more truths to light.
All right, Section 4, blockchain beyond currency. Let's move ahead and see how this builds into programmable ecosystems that transition us from just basic digital money into entirely new frontiers.
Now, the absolute game changer here is smart contracts. These are basically self-executing programs living right on the blockchain, and they automatically run the second predefined conditions are met. When Vitalik Buterin's Ethereum introduced the Ethereum virtual machine, it fundamentally changed the whole landscape by essentially making code as law. Think about it. You no longer need a lawyer or an escrow agent sitting in the middle. The code itself executes the agreement automatically.
And these smart contracts, they have incredibly diverse applications. They're disrupting traditional finance through DeFi, which enables decentralized lending and borrowing totally without banks. They're completely revolutionizing digital art and ownership through NFTs by introducing real digital scarcity. And they're even transforming supply chain management. We're talking about transparent, tamper-proof traceability for global shipping, letting you track products from their exact origin all the way to the consumer.
Finally, we arrive at Section 5, the decentralized future, scaling and society. This is where we examine the real scaling challenges and look at the ultimate vision of a decentralized society.
So to achieve true global scale, we really have to look at Layer 2 solutions, like the Lightning Network. The mechanics here elegantly solve the whole blockchain scalability paradox. Here's how it works. Step 1, you lock funds in an off-chain channel. Step 2, you conduct rapid, near-instant microtransactions off the main network, which completely avoids all that congestion and those high fees. And then step 3, you only settle the final state back on the main blockchain. It's incredibly efficient.
But look, we have to be impartial here. There are very real-world obstacles facing widespread blockchain adoption. For one, there are intense environmental debates around the huge energy footprint of proof-of-work mining. We're also seeing widely varied regulatory responses globally, everything from outright bans to highly comprehensive legal frameworks. Then you have ongoing security challenges, like exchange hacks and 51% attacks. And finally, there's the incredibly complex issue of interoperability, basically building secure bridges so that all these different blockchains can actually seamlessly communicate with each other.
Despite all that, the overarching vision still points us toward Web 3.0. This is the decentralized internet. It integrates blockchain to empower users with true ownership of their data, real privacy, and direct peer-to-peer interactions. And honestly, what's so incredible about this is how directly this modern concept of Web 3.0 connects right back to that original 1980s cypherpunk ethos of individual empowerment and data sovereignty we talked about earlier.
Which really leaves us with a pretty profound question to chew on. As we navigate all this scalability, regulation, and incredibly rapid innovation, will the decentralized future truly return power to the individual? It's this massive, unfolding legacy happening right before our eyes, and it is seriously challenging our traditional notions of trust and authority.
For the complete deep dive, own the paperback. Get your high-quality paperback edition on Amazon via the link in the description. Add it to your collection today. Please share this video and check the description for more.